Hello everyone, we are Vitalize and this is our device for the 3D audio. We're trying to make a device that helps drivers become aware of incoming emergency vehicles, which is known as emergency vehicle detection. The purpose of this device is to make sure drivers are aware of incoming emergency vehicles in time to safely pull over and give them the right of way. We are trying to make something that is reliable and properly relays the information of the direction of the emergency vehicle to the driver in time. The problem being addressed is that with today's cars having better audio insulation from the outside sounds, it becomes increasingly hard for drivers to become aware that an emergency vehicle is incoming early enough to safely yield the road to them. When they do hear the sirens, they don't always know where to pull over to. This requires them taking their eyes off the road and scanning around to get a visual of the emergency vehicle. If they don't react in time, they can become startled as the emergency vehicle draws closer to them in proximity. This possibly obstructs the emergency vehicle, potentially increasing emergency response time, besides the risk of them colliding with a vehicle that isn't aware of them coming in fast. Some existing solutions have been developed in Sweden by a group of students. This includes a system that an ambulance or a police car coming in can start and send a message through the FM radio of a car that lets them know that a vehicle is coming and they should probably yield the road to them. It's going to warn them of the incoming vehicle and also transmit a message that is going to be relayed on the vehicle's display system, explaining the same information of that a vehicle is coming. Another solution has been developed by Sirens, and it's their emergency vehicle detection. Sirens is an automotive software company that uses internal microphones to localize sirens. They have compiled different types of sirens that their microphones can pick up. They also cancel the sound waves coming from the car's music playback and alerts the drivers of the direction of the emergency vehicle when it detects one. It lowers the volume of the playback and lets them know that the vehicle is coming, as well as the direction of where it's coming from. Hyundai has also been developing a method to localize nearby vehicles using also internal microphones. Only this time, they use a difference in the arrival of the sound waves to the microphones instead of the sound intensity to localize the location of the vehicles. This isn't just for emergency vehicles, but overall vehicles nearby a car. Now, the problem with these solutions are that some of these solutions don't relay the direction of the incoming vehicle, like the first one we saw in Sweden. They just relay that the vehicle is coming in and the driver still has to look around to know where it's coming from and where to go. Due to that, the product cannot help the driver know where to yield and where it's safe to go. Also, internal microphones aren't always reliable as they pick up the audio from the inside the car, like the music and the conversations happening inside the vehicle. Accuracy problems can also arise when keeping track of the location of many vehicles, like the Hyundai research. Additionally, Hyundai's research does not specifically tackle the emergency vehicle detection. Our solution hopes to address these challenges by equipping a car with the ability to know and relay the location of incoming vehicles through external microphones. We hope this can be done by the microphones recognizing a wide array of siren types and alerting the driver to pull over or yield in time. With external microphones, only sounds from outside the car are picked up, making recognition of sirens not interfere with other audio playback. Once a siren is picked up, the audio system in the car could be muted, and the driver can use the siren itself as an indicator of the distance between him and the emergency vehicle coming in. The target population includes the public that drives, of course, and hope this can help them yield and yield safely to emergency vehicles.
So this is the prototype or wireframe for our solution. Here, as you can all see, there's an emergency vehicle which is approaching the road. And what happens is that this vehicle will initially sound its siren for the vehicles in front of it to be able to properly hear it. Then the microphones in the car system that have been fitted in places which are concealed outside the car so that the voice can be easily recognized come into play. Now, these microphones record the siren and then compute the direction of the audio of the sirens, and in turn, two internal sounds are played after the music system of the car has been lowered. The first sound is the one that allows the driver to know the direction of the approaching vehicle. And then there's another sound that is played for the driver, which allows him to understand that he needs to move to a certain direction. It could be left or right, depending upon where the emergency vehicle is. Next, once the driver gives way, the emergency vehicle can freely go through. This not only helps in saving lives, but it may also be crucial in catching criminals. Next, the functionality of our solution is that it recognizes all types of sirens. So these need to be pre-programmed into the database. All these sirens include emergency vehicles like ambulances, fire trucks, police vehicles. Then next, it is supposed to compute the audio in a way that not only the direction of the vehicle can be understood, but also so that the driver knows where to move the car in order to yield passage. Now, not only does this compute audio and produce the required output, but it also lowers the existing volume of the music system. This way, not only the driver is able to hear the vehicle approach towards them, but is also able to clearly understand the direction of the vehicle. Next, we call this project a success if and only if it is able to differentiate the sirens from the entire traffic. And on doing so, it is able to properly compute the directional audio and output it to the driver so that he or she can yield passage. The system also needs to provide the driver with another audio cue that will allow them to understand what direction they need to move to. Now, as all projects, we have some challenges as well. Now, the primary challenge remains to differentiating the audio of sirens from the entire traffic and to compute the exact direction from which the emergency vehicle is approaching. Now, in order to do this, we also have to compile the entire list of all different types of sirens, because each and every emergency vehicle has a different type of siren. They may change with cities or states. We also have to find places in the car where these can be fitted optimally so that it does not affect the aerodynamics of the car and is able to grab the maximum possible audio from the street. Another challenge that remains for us is to gain access to all the components that will be required, which include microphones, an array of microphones that will be installed throughout the backside of the car, and a device where we can properly compute and output our sound that has been computed. Next, in order to overcome these challenges, our team is prepared to learn any necessary languages or technologies that may help us. And we are also willing to record multiple siren types by going to fire stations, police stations, or hospitals so that we are able to get a database of different types of sirens. Now, the final piece, that where do we perform this experiment, that we're hoping to get access to the simulations lab at the University of Florida in order to compute the different sound directions at various different inputs and to test the output that has been produced in the simulation itself. We thank you all for being patient listeners.